Hello students, in this session of carbon and its compound, we will be learning about the carbon, why it's so versatile and how the carbon actually forms the bonding. So carbon, you all know very well, it is a non-metal with the symbol C, and in all the living organisms, we found the carbon, all the living organisms are actually being based upon this carbon, that is why students, the compound made up of carbon are actually being called as organic compound. Carbon has three isotopes. Do you know what are those? Carbon 12, carbon 13, carbon 14. You must have studied them in the structure of atom in your class 9. And carbon is known as, students, a versatile element. Why so versatile? Why it is so important, students? That is all we are going to learn in this lecture. Carbon, if I talk about, in the universe about its availability, then it is the fourth most abundant element in the universe, After your hydrogen, helium and oxygen, then comes the carbon when we talk about its abundance in the universe. And when I talk about its abundance in a human body, then carbon falls on the second place, Which one falls on the first place, guys? From the lungs, it is pretty much clear to you guys, that oxygen is the first, which is being present abundantly in the human body, Now, this carbon, how does the bonding in the carbon actually take place? But before that, my first question is that why does the carbon actually forms the bond, We all know the basic reason is that these elements, students, want to achieve the stability, they all want to become a noble gas, In order to do so, they actually forms the bond. Now, how the carbon actually forms the bond? Carbon forms only, students, what? The covalent bond. Or carbon only forms, students, what? The covalent bond. Why is it so? See, carbon has the two options, Till here, we have studied that generally by gaining and losing the electron, elements achieve the stability. But here also, students, we have the two options with the carbon, same as that of the gaining and losing of the electron. So first case says that it could gain 4 electrons, forming the C4 minus anion, and over here it could lose 4 electrons, forming the, students, C4 plus cation, What should the carbon do over here? Carbon does, students, none of these options, Why is it so? Because if carbon loses, students, 4 electron and or carbon gains 4 electron, then there will be, in this case, let me explain you that on gaining the 4 electron, it will be actually having the 10 electrons, And on gaining, students, 10 electron, negative charge actually increases and it would be difficult for the nucleus to hold on that much of the negative charge, And in this case, students, if it loses the 4 electron, then it would require a lot of energy to lose, students, the 4 electron, and students, the remaining 2 electron will remain as such. So the atom will become actually unstable in order to do so. So what should the carbon do? Carbon actually, forms the covalent bonding by the sharing of electron, Carbon neither gains, carbon neither lose the electron. It actually shares the electron with the another, students, element, So what is this covalent bonding? The bonding which is being formed in case of carbon is actually being called as the covalent bonding. So a chemical bond formed between the two atoms, It could be of the same element or it could be of the different elements, students, Between the two atoms of the different element, By what? By sharing of electron, guys, By the sharing of electron is called as the covalent bonding, How does it exactly take place? We have an atom A, we have an atom B. Now, these have, students, the unpaired valence electron, This will be called as a pair, this will be called as a pair. So, these are the paired electron, Now, these 1 is actually being left as the unpaired electron, in these two atoms. Now, what they are actually going to do, they will share these 1 electron with one another and forms, students, a covalent molecule, Over here, students, sharing of the available valence electron, 1 electron is being shared by adjacent, students, atoms. So, forming the covalent molecule, covalent, students, bond is actually being created, between the two. So equal amount of sharing of the electron is actually being done. Okay, equal sharing is being done, then only the students, okay, covalent bond is actually being formed between the two, or it will be called as the covalent molecule or the compound, guys. Okay, so we have like that so many examples. Okay, but the type of bonds first we have to understand. Okay, that is the classification of bond. How many types of bond do we have over here? Okay, or how many types of bond then can be formed, the students, okay, covalently. So first one we have over here is the single covalent bond, in which the example we have over here is of the hydrogen molecule and the chlorine molecule, in which they are actually sharing one electron, students. Okay, one is being shared by this hydrogen atom, one is being shared by this hydrogen atom, and forming, students, what? A single covalent bond. Okay, they are actually forming the single covalent bond. Same is the case with the chlorine. It is sharing one electron, and this chlorine atom is actually sharing one electron. So they are forming a single covalent bond. Okay, we have the double covalent bond also, in which a pair of electron, okay, a pair of electron, because the 2 electron is being shared by this atom, 2 electron is being shared by this atom, so forming the O2 molecule. Okay, in case of CO2, it is sharing, the students, one pair. It is sharing one pair with this oxygen. Okay, and carbon is also sharing one pair of electron with this oxygen. Okay, and forming the CO2 molecule. Okay, we have the triple covalent bond also, in which one atom actually shares 3 electron. Okay, another atom shares 3 electron, and forming the triple bond with one another. So such type of bonds are actually being formed, okay, in the students, okay, carbon and its compound, or we can say that the covalent bond which are actually being possible over here. Okay, now we have, students, okay, different examples like how this covalent bonding exactly take place. The first example we have over here is of ammonia, in which we have the nitrogen, okay, having, students, okay, 5 valence electron, and hydrogen having only the 1 valence electron. Okay, so in the formation of ammonia, the nitrogen only, students, okay, will share 1 electron. Okay, in the ammonia, nitrogen will share only 1 electron with 1 hydrogen. Okay, it won't share all of its 5, or if it has, students, any extra electron, then it is actually going to share it with the hydrogen. Okay, so it only share equal amount of sharing. Okay, what I mean to say basically is that equal amount of sharing actually take place. Okay, and that result in the formation of, students, okay, the ammonia molecule. And the 2 electron which you are observing over here, the pair of electron, is actually being called as the lone pair. Okay, so this one, the shared one, will be called as the shared pair of electron, and the left one will be called as the lone pair. Okay, lone means loneliness, likewise you can relate. So here we have taken, students, okay, 3 hydrogen, and 3 hydrogens are actually being, okay, bonded with 1 nitrogen and forming the NH3 molecule, that is the ammonia. Okay, we have over here, students, okay, carbon and oxygen. Okay, the 2 oxygen that are clearly visible to you over here. Okay, so in this case, students, okay, 1 pair of electron is being shared by this carbon, 1 pair of electron is being shared by this oxygen, okay, forming, students, a covalent molecule. Okay, CO2 molecule is being formed. Okay, same is the case is being done by this oxygen and this carbon, students. Okay, so oxygen and carbon, students, okay, are combining. 2 oxygen atoms are being combined with 1 carbon atom, okay, and forming the CO2 molecule like this. Now, the allotropes of carbon we have over here. Allotrope is what? Or allotropy is basically a phenomena we have over here. Okay, so the phenomena of existence of the element in 2 or more forms. Okay, it is existing in 2 or more form, have, students, different physical property but identical chemical property. That means the element is same. Okay, but the physical properties are different, so that creates, or that makes it, students, into a different substance. We have the allotropes of carbon like your diamond, graphite and fullerene. Okay, 3 allotropes of carbon we have over here. So let's talk about the first one, that is the diamond. Okay, as you all know very well, students, okay, the diamond. So diamond is basically an allotrope of carbon. Okay, so in diamond, each carbon atom is covalently bonded to 4 other carbon atoms. Okay, 1 carbon atom, as I take the example of this one, for example, is being bonded, okay, with the 4 other carbon atoms, okay. And students, okay, this carbon atom has a tetrahedral arrangement, okay. It actually has the tetrahedral arrangement in which one carbon atom is actually being bonded with the students, okay, 4 others, okay, forming a tetrahedral arrangement of the molecule, students, okay, over here. So in diamond, okay, the structure is like that, okay, and all carbon atoms, students, okay, are actually being tightly packed, okay. It has, students, okay, a tetrahedral arrangement of these atoms, okay. Next one we have over here is the graphite, in which, students, okay, in a crystal of the graphite, okay, the carbon atoms are being arranged in an hexagonal pattern, okay, not tetrahedral now, hexagonal pattern is there in the parallel planes, okay. As you can see, we have one plane over here like that, and another plane is lying just below it. So it is like a plates, okay, parallel plates, okay, which are sliding over one another. So in a layer of a graphite, okay, each carbon atom is strongly bonded with the 3 other carbon atoms, okay. One carbon atom is actually strongly bonded with the 3 other only, okay. This one is being bonded with this, this and this, okay. Likewise, this one is being bonded with this, this and this, students, okay, forming an hexagonal pattern over there, and they are actually being covalently bonded with one another, okay. Now, one valence electron of each carbon atom is free in every layer of the graphite, okay. One, as it is being said over here, they are strongly bonded to the 3 students, okay, other carbons, and because of that, students, okay, one electron is actually being free over here. One valence electron is free in the every layer of the graphite crystal, okay, and that makes it a good conductor of electricity, because electrons are the carriers of the charge, okay. So over here, students, that makes it a good conductor of electricity. Next we have over here is the fullerene, okay. What is the fullerene? Fullerene is also an allotrope of carbon, and it has, students, okay, the 60 molecules, okay. So C60 has the, students, okay, marvelous structure, okay, containing the 20 hexagonal and 12 pentagon of carbon atom, okay. 60 are basically or the carbon atom, okay. 60 molecules are not there. C60 is basically a complete molecule in which we have the 60 carbon atoms, okay, which are actually being present, students, okay, into this fullerene, and they are also being bonded, students, okay, covalently with one another, okay. If you want to know, students, okay, the 20 hexagonal and 12 pentagons, how they are actually being connected, okay. So over here you can find out, students, okay, the 5 carbons are being bonded together, likewise, and the hexagon is also being created, okay, in this, students, fullerene, okay. We have over here another fullerenes, okay, like your C60, the one which is mean. Otherwise, students, okay, we have C70, C74, okay, C78 also, okay. The other forms of the, students, okay, or they are also being called as the other members of the fullerene family. But C60 is actually the most stable and the most, students, okay, studied form of the fullerene, okay. Most stable and most studied form of the fullerene is being called as this, students, okay, C60 fullerene, okay. Now, the next we have over here, students, okay, is the versatile nature of carbon, okay. How the carbon is so versatile? Carbon is so versatile because of the catenation, because of the, students, okay, tetravalency, which is being formed by this carbon. Carbon has the tendency to form the multiple bond, and carbon also, students, okay, do the isomerism, okay. So what is this catenation? First property, catenation says that the property of forming the bond, okay, with the atoms of the same element. That means carbon has a tendency that it can combine with the same element, that is the carbon, in, students, okay, a numerous manner, okay. So carbon is combining and forming a complete chain over there, okay. By combining, students, okay, it can create a long chain, okay. The chain can be of your 3 also, 4, 5, 6, 7, 8, and likewise, students, okay. So this property is being called as the catenation, like the chains are being connected now, okay. So one single, students, okay, that ring is being connected with the another one. So likewise, one carbon is being connected to the others, okay. So same is the case we have over here in case of carbon compounds, okay, and that property is actually being called as the catenation. The next one we have over here, students, okay, is that what type of chain is actually being formed by this carbon. So we have a straight chain in which all the carbons are being connected in a straight manner. We have a branch chain in which, students, okay, a branch can also be created, okay. In a straight chain, the branches can also be created, students, okay, that makes it a different compound, okay. Likewise, we have the branch chain, we have the closed chain in which, students, okay, a closed circuit you can call it, okay, in which all the carbon atoms, okay, are being connected to one another, okay. All the carbon atoms are actually being connected. It is not an open structure. This is basically a closed structure. That is why the name is being given with the cyclo, students, okay, written as a prefix over here, okay. So cyclopropane, cyclohexane, cyclobutane we have over here in this case, okay. Now, the tetravalency of the carbon, how the carbon is tetravalent to one another, students, okay. Carbon has the 4 electron present in its outermost shell, as you can see, okay, and it has a tendency, students, okay, to share these 4 electron, okay. These 4 electron it can share with the another atom and can covalently bond with that atom, students, okay. So that is why it can connect with the 4 different elements, okay, in one single go, okay. So 4 different elements, 4 different atoms can be, students, okay, form the covalent bond with this carbon, okay. And the tendency to form the multiple bond, okay, carbon not only forms the single bond, students, that is form or can combine by sharing only one electron. No, it can combine, students, by sharing a pair also, by sharing, students, okay, 3 electrons also, okay, with the other atom. Okay, so tendency of forming a multiple bond also make this carbon, students, okay, so versatile in nature. The last versatile property we have over here is the isomerism, okay. Isomerism is basically a phenomena in which the compound having the same molecular formula but the different structural formula is there are known as the isomers, and the phenomena of the existence of this isomers is called as the isomerism. Example we are taking over here is of pentane, which has the formula C5H12, okay. So how we can connect this C5H12? We can connect it into a straight manner, guys, okay, in which all the carbons are being connected in a straight chain, okay. So this is one formula we have over here in which the molecular formula is C5H12, okay. The name is pentane we have over here, but over here, students, okay, a branch is actually being created. Now the formula is same, but students, the name is different. Over here also, students, okay, it is, or this compound has the formula, students, C5H12, but the name is different likewise, okay. So as the number of the carbon increases, okay, in the compound, number of isomerism also, students, okay, increases. Now it's time for some questions, students, okay. Let's see what you have understood from the lecture. Covalent bonding, okay, is least likely to be formed in, okay, between the different element of the group 7, students, okay, or in a substance with the high melting and the boiling point, in the compound with the low melting and the boiling point, or between the element, okay, in the group 1 and the element in the group 7. So we all know very well, okay, in the group, students, okay, 1 and the group 7 more likely to be formed, students, okay, ionic bonding, okay, not by sharing of the electron the students, okay, form the compound, but by gaining or losing of the electron, okay. These are basically the metals, these are halogens, okay. So they actually combine, okay, by forming, students, what? The ionic bond, okay. They form the compound by the formation of ionic bond, students, okay, or ionically they actually combine with one another. So option D we are going to go with over here as our answer, okay. So covalent bonding is least likely to be formed in the first and the 7th group, students, okay. Next question we have over here says that which hydrocarbon exists isomerism, okay, in which case we are actually going to obtain or we will be able to see the isomerism, okay. In case of ethane, okay, we have only the 2 carbons, okay. So in this isomerism is not possible. In case of propane we have, students, okay, the 3 carbon. In that also, students, isomerism is not possible because we cannot create a branch or, students, okay, another, basically the formula, okay. So over here, students, in case of methane we have only 1 carbon, but in case of butane, okay, we have the 4 carbons, okay, and in that, students, okay, isomerism can be possible by creating students, okay, a branch over here, okay, that will give you students, okay, the existence of isomerism, okay, and that can be easily seen in case of butane, okay. So option C is going to be C for the carbon, okay, will be the answer. Next question we have over here says that which of the following statement about the diamond is correct, okay. Diamond is the crystalline, students, okay, a crystal in a giant molecule of carbon atom, okay. A diamond crystal is a giant molecule of carbon atom. Yes, correct, okay. It is a giant molecule, complex molecule, students, okay. Each carbon atom, okay, in a diamond crystal is being linked to the 4 other carbon. Yes, correct, okay, by the strong ionic bond. No, students, okay, they are covalently bonded with one another, okay. Diamond does not conduct electricity. Correct, okay, that is the property. The melting point of diamond is more than 3500 degrees centigrade. Yes, that is also correct, guys, okay. So answer is going to be the option B over here, okay. Option B, which is incorrect, okay. They are covalently bonded, they are not ionically bonded to one another, okay. Next one we have over here says that which of the following statement is correct, okay. Buckminster fullerene, okay, is an allotrope of sulfur. No. Buckminster fullerene, okay, is a liquid at room temperature. No. Buckminster fullerene, okay, is made up of 60 sulfur atom, okay, are being joined together. No, okay, they are the carbon. Buckminster fullerene gives nitrogen oxide on burning in the oxygen. No, students, okay. So all the statements are incorrect over here. It is being asked us the correct statement in the question. So we are going to go with none of these as the answer in this case, okay. So option, students, okay, last one, that is the E will be the answer like that, okay. So I hope you have understood the topic, students, okay, the basic introduction, how the carbon is so versatile, okay. I will see you guys in the another one. Thank you.